It's a brief video about how multiplication is the only operation that distributes over addition. Here's what I mean. Ask yourself, do you agree with that statement there? I hope you do, because of course we're used to distributing the 3 times over the sum of terms in the bracket. 3 times 4 and 3 times 1, and we know that that works. Let's try it with other operations. Is 3 divided by 4 plus 1 the same as 3 divided by 4 plus 3 divided by 1? Quick mental calculation, you'll find that that's nonsense, clearly not true. What about raising to the power 3? 4 plus 1 cubed. Is that the same as 4 cubed plus 1 cubed? No, that doesn't seem to work either. What about square rooting? No, we don't seem to be getting anywhere here. But of course, we've just seen that raising to the power 3 doesn't distribute over addition. And here, raising to the power a half, which is what a square root is, does not distribute over addition. So powers in general do not distribute over addition. What about sine? Does sine of 4 plus 1 distribute? No, sine 4 plus 1, which is of course sine of 5, is not equal to sine of 4 plus sine of 1. Can't do it, it's wrong. And what about log of 4 plus 1? Is that the same as log of 4 plus log of 1? Nope, that doesn't work either. So it looks like the only operation that distributes over addition is this humble friend here, multiplication. Even our other humble friend, addition, doesn't work. Addition does not distribute over addition. You probably recognise this statement here as if you've come across the Associativity Rule. You might have seen we can change the brackets around here. I can swap the brackets so that they go over the 3 and the 4 instead, and we find that the expression equals the same wherever you put the brackets. That's because addition is associative. But in this case, we're not interested in associativity here. We're interested in whether addition or an operation distributes over addition. And addition itself does not actually work, as we can see there. There are some interesting facts here. Because look, if we put the divide the other side and take 4 plus 1 and divide all of that by 3, we find that it does work. But really what we're doing here is not so much division, but still multiplication, just by a third. So let's change that divide by 3 to times a third, and we find that really what we've just done is a multiplication. And of course we've already seen that multiplication does distribute over addition. What about integration? Is that true? And the answer is actually yes. So have we found another operation other than multiplication that distributes over addition? Well, sadly, no. Again, we haven't, because this is 4 plus 1 multiplied by dx. We're really doing dx times this bracket. So we're really doing something that we've done before already. We've already seen that multiplication is distributive over addition. Now the S here is a big long sum. We're just summing up, adding up lots of examples of doing 4 plus 1 as a sum of terms times dx. So you don't need to worry too much about that, but just take it from me at the moment that fundamentally what we're doing in this example is still just a multiplication, and we've already seen that multiplication distributes over addition. Here's an interesting one just before I finish. Here we have something that is true. Why? Because, well, let's write it as power a half. We know this is one of the laws of indices. I think it's possibly the 3rd law of indices. Powers do distribute over multiplication. So remember, the sort of operation inside here is a times b, and we've still got the times here. So we can say that raising to the power, or powers, do distribute over multiplication, because this thing that's written here is true. But everything else in this video is not about distributing over multiplication, it was about distributing over addition. So this is a separate example. Just to summarise here, multiplication is the only operation that distributes over addition. Up to A level, at least.